Hello, welcome. In this tutorial we'll be talking about NCBI BLAST, one of the most widely used software applications in bioinformatics and related subject areas. In this video, we will see what BLAST is, the uses of BLAST, and the type of output it generates, the basic procedures, and how to interpret the results. What BLAST does is, it compares the query sequence, whether it can be a nucleotide or a protein sequence, against a database of sequences to find similar sequences. This is particularly useful for identifying homologous sequences and determining the evolutionary relationship and annotating genes or proteins. There are several different BLAST algorithms such as BLAST-N, BLAST-P, BLAST-X, T-BLAST-N. Here, BLAST-N and BLAST-P are the most common types of algorithms. BLAST-N is dedicated for nucleotide sequences and BLAST-P is for protein sequences. The other two algorithms, BLAST-X and T-BLAST-N, are a bit more advanced tools where they can translate nucleotide sequences or reverse translate protein sequences before conducting the BLAST analysis. We can choose any of these algorithms depending on the specific purpose. Furthermore, these algorithms use heuristic methods to perform fast and efficient searches against large databases. It breaks the query sequence into smaller words and searches for these words in the database sequences, extending match to find regions of high similarity. The applications of BLAST are so huge. If I highlight some of these important applications, I can say genome annotation, phylogenetic classification, functional genomics, and even medical research. For example, to identify disease-related genes or proteins by comparing against already known pathogenic sequences. Then, if I talk about the output of BLAST, it would generate alignments between the query and the database sequences. It generates the scores, including the strength of the matches, e-value or expected values, that indicating the statistical significance of each match and other relevant information. To access BLAST, the web application, which is most common form of BLAST application, we first have to visit NCBI's official web page. You can follow the link or just search in the web browser. Click on the NCBI and in the opening web page there will be a link to BLAST in the right side panel. In the BLAST window, we have links for various BLAST programs that we have already discussed. And for this tutorial, we may choose BLAST-P due to its applicability for proteomic analysis. The main BLAST-P window contains basically three different sections. That includes a section for sequence entry, a section for database selection, and a section for BLAST algorithm selection. Now let's find about the format of input sequences. Usually it is said that the input should be in FASTA format. That means the sequence must start with a greater than mark, followed by a unique header, and then the sequence of amino acid or a nucleotide sequence with legit characters. Keeping sequences in FASTA format is very important, especially when we are dealing with multiple sequences. Let's do one example and see the output. Here I have an amino acid sequence that I named as test-seq. We can paste it into a sequence entry box and then do BLAST without altering any of the parameters. Depending on the server speed and the internet connectivity, this would take some time. Once we have the result, we can see some meta details and the search outcome. To evaluate the significance of the output result, we have to check the scores generated during the analysis. Now let's talk a little bit more about these scores. Generally, the maximum score represents the statistical significance of the alignment between the query sequence and the database sequence. It is calculated based on the alignment length, alignment quality, database quality, and the similarity between sequences. The score is normalized to make it comparable across different searches. In other words, there is no universal maximum for this score, and it depends on many features related to the input and the database. Usually this score must be high when selecting the sequence related to the input sequence. The query cover, also known as a coverage, is a measure used in the sequence alignment to indicate the proportion of the query sequence that aligns with the sequences in the database. In the context of NCBI BLAST, the query sequence represents the percentage of the query sequence that is covered by the alignment with the matched sequence in the database. It provides information about how much the query sequence is represented in the alignment. Another most important score is E-value, or expected value, which is expected to be minimal to have a significant similarity. In general, it must be less than 10 to the power minus 7 when choosing alignment for significant similarity. This score is a statistical parameter that represents the number of random hits one can expect to find with a similar score or better just by chance when searching a database of a particular size. In other words, it estimates the probability of obtaining a match between the query sequence and the database sequence purely by random chance. Lastly, we must know about the percent identity, which is a measure used in sequence alignment to quantify the similarity between two sequences. It represents the percentage of positions in the aligned sequences that have identical residues for nucleotides. For example, there can be 100% sequence identity against a full or a portion of a sequence found in the database, indicating the extent of similarity. In some occasions, we can multiply coverage and percentage identity to have an overall idea about the input query sequence and the sequences obtained in alignment in the database. BLAST contains a very user-friendly environment, so we can extract much more information about the sequence of interest. We can go to the graphic summary, where we can see the coverage and the strength of the alignment in a color-coded manner, and also we can refer to the scale given in the output. More importantly, we can get information about various domain architectures by clicking on domain details. Then in the taxonomic window, we can obtain more information about the phylogenetic relationship of the query sequence and the output sequences. So far we have been talking about query sequence, search against the NCBI database. Beyond that, we can use BLAST to compare two or more sequences to one another. To do that, we have to go back to BLAST B suite and click on the checkbox. That opens a space for two sequence intersections. We can place the query sequence in the top section and the one or more sequences to be compared in the second section. Then run BLAST and we might get an output depending on the significance and also which depends on the BLAST parameters run in the background. Lastly, we can use multiple sequences in BLAST analysis that would run in a single analysis cycle. Here we have to input all the properly formatted sequences in the FASTA format. And once the analysis is done, we have access to output against each sequence by selecting the name of the sequence in the drop-down menu. We also can download the output in various different formats if you are planning for further analysis using these results. This is pretty much about basic BLAST analysis, and I hope this would be helpful to do your analysis with a proper understanding. Thank you for watching.